welcome back to my channel. Today we'll be talking about two probability distribution, binomial and Poisson distribution. The names sound heavy, but trust me, you've already seen both of these concepts in your everyday life. And let's meet Mohanji. Mohanji who runs a chai stall in his neighborhood. His business is very simple, but every day two very different kinds of questions come up at his install. Question 1: how many people who tried a free sample actually became paying customers? That is binomial distribution. Question number 2 is how many customers will walk in during a given hour? That's Poisson distribution. These two questions different, each need a different distribution to answer. Now let's break them down one at a time. The first one is binomial distribution. So Mohanji tries a new experiment. Every morning he offers a small free tester cup of chai to 20 people passing by his stall. And from the experience, he knows that 30 out of every 100 people who take a sample end up become paying customer. So that's the chance of success is 35% or 0.35. So these are two key pieces: number of trials, how many people were offered a sample. Example here was 20, and out of which the chance of success on any one trial is here with 35% chance of becoming a buyer after getting a free sample. So in each trial, only two possible outcomes: either the person becomes a buyer or they didn't. No middle ground, only two outcomes, right? Situation exactly what a binomial distribution handles. Bi means two, like a two wheels on a bicycle. So quick way to remember is this: out of fixed group, how many say yes? So two outcomes. How many say yes? A fixed head count. Each person answers only yes or no. Take a look into the Excel file, so where the Mohanji does all the calculation in Excel, so where he can know how many success rate probability when we have like about one customer, two customer, and probability of having that buyer. So the success probability create a chance a sampler becomes a buyer, 35%. So number of trials, how many people were offered a sample? 20. And expected number of buyers is number of trials into the probability. So we have, so expected is 7 outcome. Okay, so D5 into the D4. So now we have these two, the point probability exactly when we want the exact this value, so when we have no buyers at all. So that is the point probability. We will use the formula is equal to binomial distribution. B10 is the value when we want this exact value of the probability. D5 is our number of trials we are taking, and in D4 is the success probability, and false when we want the exact value which is 0. And then we have this probability. Cumulative is when we comparing the value, since it's only there's nothing before before this cell, so this is the same. In this value, this is the exact value, and this is compared with the previous value. That's the cumulative probability. So when we copy this formula to the whole, then the calculation is there. So false is exact point probability of getting exactly X buyers. True is cumulative probability of getting X buyers or fewer, and most likely outcome is number of trials into probability, and that change D4 D5 to, so if you change the values, and it will change automatically into here. And we in this chart we have a look. So higher the number of the buyers, if 7, there's a higher probability, because there is a 35% of that. That is the expected outcome. For lesser, there's a lesser probability. For higher, there's a lesser probability. So this is the formula, and then we can know, right, what is the chance of getting 5 buyers or fewer, and simply change the, if we want the exact 5, then we can just change the argument uh, from true to false. When we want exact the number of buyers 5, if we want if we want to know how many buyers 5 or less, then we can change the last argument to false to true. So let me go through this whole this binomial distribution again. So in this D4 value, he enters the success probability, which is the 35%, and in D5, yeah, in D5, number of trials, and so in here, in our B10, in B10, he lists the number of buyers, because it's possible that 0 people buy, or that's and the 20 people buy. So now in this formula, we type is equal to binomial distribution B10, which is the value number of successes we are checking. First row is 0, that means no one become buyer, and in D5, that is our number of trials. That dollar sign lock this reference, so it doesn't shift when the formula is copied down. And now this D4 is success probability, which is also locked, also become absolute reference. When we copy down the formula, this reference won't change. And the false is when we want the exact probability of one specific value, that is called point probability. So once the formula is copied down, the whole column, we get a chart showing number of buyers most likely. So key insight is there. So when we number of trials into the probability of success, we expected outcome is 7 buyers, exactly what we expect. The chart peak around the 7, the most days result fall somewhere around 4 to 11 buyers. Now switching to the cumulative probability, if the Mohanji wants to know what the chance of getting 5 buyers or less, or 4 buyers or less, so we can have if we want to know 5 buyers or less, he has a chance around approx 24% chance. 6 or more less, that's around 41%. 7 or less, there's a 60% chance. So comparing this 14 or 15, there is a chance of 99.9%, or this 15 is 100%. So that tell us getting more than 15 buyers is practically impossible. Let's say 13 or 4, more than 14 buyers is practically impossible. So if his target is more than 10 buyers a day, he needs to change approach, either offer sample to more people or improve the sample itself so that success rate climbs above 35%. Right? Now our next is the Poisson distribution. Poisson distribution, a very different kind of question. Now for Mohanji, second question, how many customer will walk into his stall in an hour? So this is not a binomial question because there's no fixed list of 20 people to check yes or no against. Instead, we're counting random arrivals over a continuous stretch of time, 1 hour. This is where a Poisson distribution comes in. So the Poisson distribution works off average rate, which is the lambda, and calculates the probability around it. And Mohanji data shows his stall gets an average of 7 customer per hour. Their lambda is 7. So quick way to remember is Poisson is how busy will it get when only know when we only know the lambda average, not the exact count. Like customer arriving at chai install, sometimes 3, sometimes 10, but average out to the 7. So average covers 7 customer arriving per hour. This is our lambda. No fixed list of people, just a window of time. So this Poisson distribution we are using when we are counting random events over continuous time or space. Right, now we'll see it into the Excel file as how we calculate this Poisson distribution. Calculate the Poisson distribution into the Excel files. We have average customer per hour is 7. How many customer arrive per hour based on the average rate, based on the lambda, which is 7. So this is the number of customer, like no customer arriving in that hour. Then we getting the exact value, right? And the way we use the formula is equal to Poisson customer and number of the in B8 number of customer arrived. So if it's none, that is 0. So in our D4, which we have our lambda, which is our reference, fixed reference, we want this number to change when we copy down this formula. False when we want to know the exact value, exact probability of getting that number, that 0. So getting exactly 0 customer in hour is quite rare, which is under 1% or 0.09%. Once we copy down the formula, we will see around 7 customer. There is a most likely outcome, which is approx 50% chance, and our average value very close to 7 and 6 and 8. So carry a good chance, right? So it's around 7, there's a good chance because the expected outcome is 7, our average is 7, there's a most probability sits around. And when we let's take a look at cumulative, just like binomial, changing the last argument to true give us the cumulative probability. So that this tells us between 0 to 5 customer arriving only, right? 0 to 5 approx 30% chance. A slow hour, like that's fairly rare. 0 to 10 there is approximately 90% chance. When we further out we go, closer to the further value, closer to the chance to get 100%, right? That's the 100%. So that's notes, false exact value, exactly the X customer arriving in hour. True is cumulative probability of X customer of future arriving in that hour. Poisson will only works with the whole number and is an inverse of exponential distribution, which is uses the 1 by lambda, but we are using here the lambda, not the exponential. Poisson also only works with the whole number, not with the decimal numbers. We can't say 7.5 or 6.5. No, it's there is no decimal. There's only either 1 or either 2, either 5 or 6, 7, 8, 9, 10. So Poisson can be thought of the inverse of expansion distribution, exponential using 1 by lambda, average gap in time between events, while the Poisson uses lambda directly with the average count. So now let's line up these two situations side by side. So in binomial, we ask question out of fixed group, how many say yes, right? And in Poisson distribution, we say how many random events in that time period. What is fixed? Number of trials. And here, what is fixed? A stretch of time or space, 1 hour time. What inputs we needed? Number of trials and probability of success. And here we need the average rate, which is lambda. So in this example, we are talking about 20 sample and 35% success rate. And in here, we have our, what fixed is there is if it's 7 customers per hour. So simple rule of thumb is if you have fixed number of chances, each one has says 2 outcomes, yes or no, use binomial distribution. So if you are taking the example of counting random events across time or space, you only knows the lambda average, right? Use Poisson distribution, right? So this is not only about the chai install for environmental testing. Use the same distribution, like when a batch of sample test is passed, or say that is the binomial distribution. Say for contamination, result looks a lot like a binomial setup. When microbial colonies on a agar plate are counted, these counts are often follow Poisson pattern. So this stats is not just a textbook theory, it's beyond real quality control decision. So next time you see a free sample at a show and notice how busy a stall gets, you will know exactly which stat is running behind the scene. If you found this video helpful, don't forget to like, subscribe, and I'll see you in the next video.